Hello everyone, my name is Nishant Sachdeva. I am working as Assistant Professor in Civil Engineering Department of Swami Keshwanand Institute of Technology, Management and Gramothan, Jaipur. Today we'll be discussing a topic rotary intersection design as per Indian Road Congress Code IRC 65/1976. The contents of my presentation includes first, introduction to rotary intersection, which includes definition of rotary intersections, advantages and disadvantages of rotary intersections, guidelines for selection of rotary as per IRC. The second topic includes design elements which are required for the designing of rotary intersection, and further we'll solve a numerical problem as well. We'll start with the introduction part. Firstly, what is rotary intersection? Rotary intersection, which are also known as roundabouts, are special form of at-grade intersections laid out for the movement of traffic in one direction around a central traffic island. The vehicles entering the rotary are generally forced to move in clockwise direction in orderly fashion. In case of moderate flow of traffic, we do not prefer a signalized intersection. In those four-legged intersection, we provide a rotary intersection in which there is no need of stopping of vehicles. The vehicles move in clockwise direction around the rotary and there is free flow of traffic. There are many advantages of rotary intersection. I'll discuss them one by one. First is traffic flow is regulated to only one direction of movement, thus eliminating severe conflict points between crossing movements. Conflict points are those points on which there is a possibility of an accident or collision, so the conflict points are reduced. I'll show in the next slide how the conflict points are reduced. Second, all the vehicles entering the rotary are gently forced to reduce their speed. Thus, due to reduction in speed, the accident severity is reduced and there is no need of stopping of vehicles as well. The rotaries are self-governing, hence there is no need of any traffic constable or traffic policeman, or there is no need of any traffic signal on a rotary. The rotary is ideally suited for moderate traffic, especially in irregular geometry or intersections with more than 3 approaches. I was talking about conflict points. This is the diagram of a conflict point at a four-legged intersection. You can see at a four-legged intersection, there are a total of 32 conflict points, which includes diverging, merging as well as crossing traffic. There is a possibility at 32 points on which an accident can take place. In a three-legged intersection, there are 9 points on which there is a possibility of an intersection, but at a rotary intersection, the vehicles have to travel in clockwise direction along the periphery of the rotary, so the conflict point reduces to 8. So there is least possibility of accident. Since the speed of the vehicle is also reduced, so the severity of accident can also be reduced. There are few disadvantages of rotary intersection as well. First one is all the vehicles are forced to slow down, so the delay at rotary intersection is comparatively high as compared to channelized intersection. If they even in case of low traffic, when the traffic is very low, if we consider at night or at afternoon when the traffic is low, even at that time as well, the vehicle will have to lower down the speed. The area required for a rotary intersection is comparatively very high as compared to channelized or signalized intersection. The vehicles do not usually stop at the rotary intersection. They accelerate and exit the rotary at a very high speed, so it is not very much feasible for high pedestrian movement. There are few guidelines for selection of rotary as per the Indian Road Congress norms. The first guideline is there must be a minimum of 4 approach roads for a rotary intersection. The vehicle count also plays a very important role. The vehicle count at a four-legged intersection must be a minimum of 500 vehicles per hour and a maximum of 3000 vehicles per hour. This 500 and 3000 vehicles are in a unit of passenger car unit PCU. The PCU is determined by counting the vehicles at an intersection. The Vehicles which use the roads includes two-wheelers, four-wheelers, trucks, bullock carts, cycles, etc. These all vehicles are number of vehicles are multiplied by a equivalency factor and converted into a single unit known as passenger car unit. Below 500, there is no need of any rotary, channelized or signalized intersection, and above 3000, the rotary intersections are not feasible. We have to go with the signalized intersection. Rotary intersections are suitable for 4 or more than 4 approaches. Rotary intersections are very highly beneficial when the percentage of right turning traffic is greater than 30%. I'll move towards the design elements for a rotary. This is a typical diagram of a rotary. In this diagram, I'll take this portion. In this portion, the vehicle will approach towards the rotary from this side. So this is entry width, and leave the rotary from this side. So this is exit width. This is entry radius and this is exit radius. This is also known as radius of central island. This is the weaving section. Weaving section means that area in which the vehicle will cross each other. So this is known as weaving width, and distance from entry width to exit width is known as weaving length. We have to calculate all these parameters. The specifications and formulas as per IRC 65/1976 are: first, design speed. IRC specifies a design speed of 40 km per hour for rural areas and 30 km per hour for urban areas. The entry radius for 40 km per hour in rural area will be 20 to 35 meters, and the entry radius for urban area will be 15 to 25 meters. The exit radius is kept comparatively higher than entry radius because we want the driver to accelerate the vehicle and leave the rotary as soon as possible. So it is kept as 1.5 to 2 times of entry radius, and the island radius is kept as 1.3 times of entry radius. We can find out the width of weaving section by the formula E1 plus E2 divided by 2. E1 stands for entry width and E2 stands for exit width, plus 3.5 will give us the width of weaving section. Weaving length can be determined by 4 times of weaving width. A minimum of 45 meters for rural areas and 30 meters for urban areas is specified by IRC. Now we'll calculate the capacity of the rotary. Capacity of the rotary can be determined by the formula 280W, 1 plus E by W, 1 minus P by 3 upon 1 plus W by L. Here W stands for width of weaving section. The IRC recommends the width of weaving section must be in the range of 6 to 18 meters. E stands for average entry width. IRC recommends E by W ratio of 0.4 to 1. L stands for weaving length. W by L ratio must be between 0.12 to 4, and the proportion of weaving traffic is determined by P, which should be between 0.4 to 1. I'll show in the next slides how to determine the proportion of weaving traffic. Let's take an example. The width of approaches for an rotary intersection in an urban area is 12 meters. The entry and exit width of a rotary is 10 meters. Table below gives the traffic from the 4 approaches traversing the intersection. Find the capacity of the rotary. In the given table, it is given that the traffic coming from north, south, east and west direction, which is going straight, turning left and turning right, is given here in PCU. We will arrange this all PCU in a diagram like this. I'll show you how we can arrange. I'll take an example of north direction. The traffic which is coming from north direction and moving towards left will follow this path. It will come from this, it will go along this and leave the rotary from this direction. So the traffic which is moving left is mentioned here as 300. The traffic which is going straight will follow this dotted path and leave the rotary by following this dotted path. So I've mentioned a traffic of 500 which is mentioned in the table here and here. The traffic which is going right will follow this path. Now it will come along the periphery of the rotary and will leave the rotary intersection following this path. So I have mentioned 400 here, 400 here and 400 here. In the similar way, for all the directions east, south and west, will have to mention the amount of traffic on these paths. Now I'll come on the design speed. In the question it is given that it's a urban area, so a design speed of 30 km per hour is recommended by IRC. the entry radius will be 15 to 25 meters for urban area, and exit radius will be 1.5 to 2 times of entry radius, and island radius will be 1.33 times of entry radius. I have discussed it earlier as well. I'll find out the width of viewing section, which is denoted by W. In the question, it is given the entry and exit width is 10 meters, so E1 and E2 are coming out to be 10 meters. The width of viewing section can be calculated as 13.5 meters. As per IRC, the width of viewing section must be between 6 to 18 meters. It is coming out to be 13.5 meters, so it is okay. Viewing length is 4 times of viewing width, so it is coming out to be 54 meters. We have to apply 2 more checks here as well. E by W ratio must be between 0.4 to 1. It is coming out to be 0.74, so it is okay. W by L ratio should be between 0.12 to 4. It is coming out to be 0.25, so it is also okay. Now we will calculate the proportion of viewing traffic. Viewing traffic is that traffic which is having a tendency to cross each other, and non-viewing traffic is that traffic which is going in parallel direction, which will not cross each other. So I'll again come to this diagram and take an example of northeast direction. In this northeast direction, this traffic will have a tendency to cross each other, 500 plus 400 plus 420 plus 400, and the total traffic in northeast direction will be this one. So the proportion of viewing traffic will be 500 plus 400 plus 420 plus 400 divided by 300 plus 500 plus 400 plus 420 plus 400 plus 350. This will give us the proportion of viewing traffic in northeast direction. Similarly, we will calculate this for east-south, southwest as well as northward direction. The highest proportion will be taken as the value of P, which is coming out to be 0.73. Now we'll calculate the capacity of the rotary. It is calculated by the formula 280W 1 plus E by W 1 minus P by 3 upon 1 plus W by L. We have calculated all the constants, that is W, E, P and L. We'll keep it in the formula, and the capacity of the rotary will be coming out to be 3980 vehicles per hour. This is a common diagram of a rotary. We will demonstrate all the parameters which we have calculated. This is entry width, which is 10 meters, exit width 10 meters. It is given in the question. This is entry radius for a design speed of 30 km per hour and urban area. Entry radius will be 15 to 25 meters. The exit radius will be 1.5 to 2 times of 1.5 times of entry radius, and the radius of rotary will be 1.3 times of entry radius. The width of viewing section is coming out to be 13.5 meters, and the length of viewing section is coming out to be 54 meters. Thank you for your time. For any further queries, you can write me to nishant.sachdeva@skit.ac.in. Thank you.